Good afternoon, students. Today we are going to study the practical, that is experiment number 4. Determine the angle of repose and influence of lubricant on angle of repose. So to consider this experiment for the understanding, first of all, we need to think much more about the need of angle of repose, understanding about the lubricant, glidant. Lubricant and glidant are basically the type of powder based on application, and all these things, this practical is useful for the to determine the flow properties, and for that we need to understand why flow properties are needed in tablet manufacturing or in capsule manufacturing. So our basic ultimate aim is to understand the tablet manufacturing, or to concentrate on the tablet manufacturing and capsule manufacturing. In the earlier lecture, we have discussed several times that during the manufacturing of tablet or during the manufacturing of capsule, what we need to focus on to the journey of powder or granules from the hopper up to the die cavity. So this is the thing we always want. In other words, we can say that our powder or our granules which we have taken for the tablet manufacturing, it should flow properly. It should flow desirably. Means the flow of granules from the hopper up to the die cavity, it should be proper. It should be desirable. So that for what we want, this flow should be proper. So that with proper flow, we can ensure that always the die cavity is going to receive specified quantity of powder every time. Every die, as we know, that die is getting circulated. Dyes are getting circulated with the help of turret, and at a particular station, that is a filling station you can say, at a particular station, the dye is getting filled by the powder or granules, which that powder is coming from the hopper up to the through the channel up to the die cavity. This process, this mechanism gives the assurity that a particular dye, if the flow would be proper, then every time the dye will get filled with specified amount of powder or granules. Means every time what we need that our die cavity should get filled with desirable powder, desirable quantity of powder, and it should be same all the time. Every die should get filled with same quantity of powder. Every die should get filled with same quantity of powder. It is itself assuring that with every tablet, after compression, we will get uniform dose. We will get the same dose every time with each manufactured tablet. So this is the basic need we are having, so that we are taking this today's practical. We are discussing this today's practical. Practical name is determine the angle of repose and influence of lubricant on angle of repose. Okay. So as you can see, or any granules you can take. Any granules you can take. And additionally, it has been told that glidant you have to take for this practical purpose. Glidant or lubricant. Now, first of all, I want to make you familiar with all these terms. Just imagine that you have to make a granule. You already made the granules, you can say. You already made the granules. Hello, am I audible? Please write it in the chat box if I am audible to you. Somehow my connection got lost. I have reconnected that. If I am audible, just please mention in the chat box. Okay. Okay. So to continue with our discussion, so what we need, we have considered that we have already made the granules of any active ingredient, and we have incorporated the glidants in that granule. So we got a blend of active and glidant. So this glidant will allow our powder or granule to flow properly, desirably from the hopper up to the diacetyl E. So what is the role of glidant then? You might have already understood. It is increasing the flowing capability of our granule. Without the glidant, the flow property will get altered. Okay, so what we need that our flow property should be proper, and we are making the use of bladder to get the proper flow property, okay, of our powder. Here, now the question will come in your mind that what is the purpose of all these things? As I already mentioned, that that we need to consider the optimum flow properties, desirable properties, so that, as you can see over here, flow properties of powder plays an important role in manufacturing of tablet and capsule. If the flow property will get varied during the manufacturing process of tablet, at particular time, small quantity of powder will come in the dye. At another time, different quantity of powder will come in different dye. Means what we will get? We will get the tablet of different weight. We will get the tablet of different weight. That is called as weight variation in the tablet. And such kind of thing is undesirable. We don't want the tablet from a particular batch with varying weight. We don't want that. So what we want? We want the tablet, all the tablets from a batch. It should be uniform. It should be same. It may happen that certain degree of variation may be there, but it should be in acceptable way. It should not be too much vast. The difference should not be too much vast. It should be in an acceptable range. Plus minus 1%, plus minus 2%. That is acceptable as compared to average weight of the tablet. Okay, so that if our flow of powder, that is the powder blend, will be proper, then what we can say, our weight variation in our whole batch or all the tablets in a particular batch will not occur. So to conclude, with proper flow, with desirable flow, we can avoid very important problem of tablet manufacturing, that is weight variation. We don't want the tablet to be varied with weight up to too much. Okay, so and this is a very common problem because the turret means a particular plate on which dyes are there, that is continuously getting revolved. We cannot see the tablet manufacturing because the speed of the turret is so much higher, and so that the flow of powder should be proper, desirable, optimum to avoid this weight variation. Okay, due to poor or irregular flow of powder from the hopper to the dye, weight variation will occur. Flow properties depends upon, now this is one of the aspects. Flow properties will also depend upon particle size. This is our granules that we have prepared. It is of which size? Are they uniform in size, or they are in variation in size? Okay. Say for example, one kind of particle will be, say for example, it would be uh, say zero point 0.5 millimeter, zero point 0.5. Okay, another would be zero point 0.6, another would be zero point 0.7, but that will create the variation in the sizes. And when variation would be there, it will definitely going to alter the flow property. So particle size, its shape, every particle shape is also going to alter or influence on the flow properties of powder. Shape. If the shapes are irregular, if the shapes are porous, another point ahead is the porosity. If the shapes are irregular, along with fracture, okay, so that it will definitely going to alter the flow properties, because every particle may create the obstacle to other particles. If the surface is too much rough and if it would be smooth, then it will definitely increase the flowability of the powder or that gel. Similarly, density with higher density particles, powder flow will be thicker. With less dense powder, it may not. Similarly, surface texture. So all of these factors will going to govern the flow properties. We are concentrating on flow properties only. Okay, I am focusing on flow properties. I am giving the multiple dimension to see the flow properties. Okay, now powder may be free flowing or cohesive. So these are the two extremities you can see for the powder. Okay, powders or granules that we are taken for the manufacturing of tablet or capsule. In the capsule also, although we are not compressing the capsule, but we are filling the capsule. So empty capsule will come into that particular station, filling station, and then again the same procedure is going to happen. From the hopper, the powder will get flown into the empty gelatin capsule at the station point, filling station point. So similar thing is needed for tablet as well as capsule manufacturing. Now, further, you need to consider the powder or the blend. Initially, we will take the powder itself, not added the glider. A powder without the glider. First, we will take. Okay. So powder may be free flowing or cohesive. At its own, powder may be free flowing or cohesive. If cohesive powder will be there, it will create the obstacle to another particle. Every particle will create the obstacle to other particles because they are having a cohesivity with each other. Cohesive force existed in their molecules. Obviously, on the surface, the molecules will be there and it will definitely go into form of cohesion. And if cohesion would be more, anyone can guess it would not allow the other particle to flow from its side. If the particle size is less than 10 micrometer, the powder is restricted. The powder flow is restricted because of cohesive forces between particles are the same magnitude as gravitational force. Earlier in another lecture, we have already studied everyone universal truth. If the particle size is getting reduced, the cohesivity will get increased. And if cohesivity will get increased, the flow will not be proper. So what we want that the powder should not be too much finer in size or it should not be too much in coarser toward the coarser side. So we want optimum powder to be there. Another factor which are contributing for the flowability is the presence of moisture. Okay, moisture can be determined by the IR or some other instruments are there. Excess amount of small particles and surface roughness leads to poor flow. So all these factors will going to contribute, will going to influence on the flow property. If surface would be rough, then friction will occur and cohesivity will get increased. Smooth surface particle improve obviously. Okay, now one example they have given, it is a dustability, which is opposite to stickiness. What we want then for desirable characteristics, it is the dustability. Okay, for this dustability means it will free flowing powders are characterized by dustability. Means the powder which is having free flow, we can say that powder is having the dustability. So we want dustability. For that, we have taken the one example. We are considering example. Lycopodium shows greatest degree of dustability, which obviously lycopodium powder. You can say it is a free flow powder, and we have considered that free flow lycopodium assigned as 100% fluidity, 100% fluidity, and if it is 100% highest fluidity, highest dustability, we have compared the dustability, flowability of another powder with respect to lycopodium. So that we got certain values. Talcum powder acting as glider, talcum powder lubricant acting as talcum powder is giving us 57% dustability. It is nearby half of the lycopodium. So you can see the degree of flowability the lycopodium is having, talcum powder is having exactly half of that. Means talcum powder is not as flowable as lycopodium. It is exactly half flowability. Capacity to flow, it is exactly half of the lycopodium for talcum powder. Similarly, for potato starch, it is 27% only. For charcoal, it is 23%. For caramel, it is 0.7%. The stability, flowability is getting reduced. Okay. So these are the examples that we need to consider. The flow rate of the tablet granulation increase will increase the quantity of fines added and the combination of the lubricant and gladants. Gladants are frequently added to granular powder to improve the flow characteristics. We already have discussed. Examples of gladants and lubricants are magnesium stearate, starch. Most of the stearates are gladants in nature. Most of the stearates. Magnesium stearate is one of them. Starch and talc. So, this is the general discussion about the flowability. Now, until now, you might have understood why flowability is needed, why we are understanding the flowability and where it is needed. It is needed in the tablet manufacturing. It is needed to assure the proper journey of the granules or powder from the hopper up to the dye casing. That means, okay. Now, first I will show you this table. Have a look on this table. Okay, properly. What we want? We want flow should be excellent. We want flow should be excellent. Okay, so that ultimately what we want, angle of repose. I am going to tell in detail about the angle of repose. First of all, we should focus on our target. Angle should be, as you can see over here, observe over here, angle lesser than 25. It is excellent flow. It will show excellent flow. Angle between 25 to 30, powder will show good flow properties. If angle would get increased, that is from 30 to 40, powder will show poor flow properties. And angle greater than 40, it is having very poor flow properties. Okay, and here you can see addition of gradient will going to improve flow properties. Okay, so what we want? We want this one. We want the powder should give us excellent flow properties. It is so obvious then what we want. We want angle of repose of our powder. It should be lesser than 25 degrees. So this is we want. You can always keep all these things, this table in your mind. 25, 25, 30, 30, 40 and 40. These are the values for that. What we want? Lesser than 25. Lesser than 25 degree of angle of repose is needed, is desirable. Now further, simple practical is there that you have to understand. Okay, we need to find out the angle of repose ultimately. We need to find out angle of repose. For that, what we need to do? As you can see over here, assembly over there, This is a funnel. This is a stand. The burette stand basically. Funnel we have attached over here. Certain kinds of assembly you have to arrange in your lab. Okay. And we have to arrange the funnel in such a manner. Okay. One by one we will take the steps. Take a clean and dry. Very important, dry. Clean and dry funnel with a round stem of 20 to 30 millimeter diameter with flat tip and attach it to the burette stand. Similar kind of assembly it has been told over here. Now, what to be done? Further, here on the bottom, we have to take the graph paper. Place a graph paper sheet below the funnel on clean and dry platform. Obviously, we are going to take. Okay. So what we want to take? We have to take the graph paper to be placed over here on the platform, just beneath the uh, just beneath the funnel. Then adjust the distance between the lower tip of the funnel and the sheet to some specified height, say 1 centimeter or 2 centimeter. Means what we have to do? This tip lower end of the funnel, the distance between lower end of the funnel and the platform, that is our paper, it should be 2 centimeter. Okay, somehow you have to adjust that. 2 centimeter. Slightly more you can get. Okay, but the distance should be proper. There should be some distance in between the lower end of the funnel and the horizontal plane graph paper. I hope you are understanding this. You can write it in the chat box if you are getting the thing. Gently. Now what to be done? We have to take the sample. First we will take the simple sample, means powder. Powder only we have to take, of which we have to find out the angle of repose. We are going to find out the angle of repose of a particular powder. You can take any powder, any active. It may be paracetamol, it may be calcium carbonate, any active you can take. Okay, so that we can take. Ultimately, we are going to form the tablet so that we are taking the active powder. So uh, gently pour sample in funnel from top till a heap of powder forms and touches the lower tip of the funnel. What we have to do? We have to go on adding our powder from the into the funnel so that from the funnel it will go down slowly and we have to add certain quantity of powder so that it should touches the our heap of the powder should get touches to the bottom of the funnel, tip of the funnel. That much quantity of powder we have to add. Okay. So with this, what we will get? We will get a heap of the powder. You can say it's a cone shape of the powder that will get resided onto a graph paper. Okay. Now you have to make the boundary, circular boundary. If you will get a circle, definitely you have to make a boundary as you can see over here in the picture, in the diagram. So heap of the powder, you have to make it with a pencil. Okay, I am going to show the video of that also. But here you have to draw the circle. Okay, around the heap. Okay, bottom part of the heap, so that you will get a circle of that. Here it has been mentioned that you have to repeat the procedure 4 times. Means 4 times you have to repeat and 4 times you have to draw this circle. 4 times. Okay. Now find out the average diameter and radius of each drawn circle as shown in figure. Now every time you will get a circle, you may not get the exact circle, but somehow you have to imagine that it is a circle, and you have to take the extreme end of that. Extreme end. Okay. 1 time, 2 times, 3 times, 4 times, because you are getting the 4 circle. Because you have done this procedure 4 times. Obviously, you will get the 4 circles, and 4 circles you will get 4 diameters. Okay, and 4 diameters. You have to take the average of that. D1 plus D2 plus D3 plus D4. You have to take the average of that. Okay. divided by 4. You will get the average of the diameter. You will get the average diameter. Now, what to be done further? You can see the table over here. Here it has been mentioned that influence of lubricant on angle of repose. Okay. So what we are doing? We are doing, first of all, we will enlist that. What we are doing? We are we have taken the powder, or you can say we have taken the granules. Okay. Here it has been mentioned that it has been they have taken 50 gram. 50 gram granules each time. Then 6 times they have repeated the procedure. 6 times they have repeated the procedure. Okay. Now, what they have done, similar procedure, they have followed with different batch. First batch, they have taken simply the granule. They have added nothing in that and followed the procedure. Okay, followed the procedure up to getting the diameter of the circle from that heap of the powder. Okay, so first reading, it is the granule, simple granule. Okay, take the circle, repeat the procedure. Hello. One more time I'll lose the connection. So will you please help me whether I am audible or not? Please tell. Yeah, we are at second batch. You can say. First batch we made and done with the evaluation with simple granules. Second batch we have done and followed the same procedure, that is with 50 gram granules plus 1% tab that we have added, and we have followed the same procedure. We got the circle from that heap, but this time it is 50 gram granules plus 1% tab. Similarly, with the next batch, again separate 50 gram granules you have to take, and you have to add 5% of talc. You will get a blend, follow the same procedure, get the circle onto the separate graph paper. Every time you have to take the separate graph paper with separate sample. Next batch, it will be 50 gram granules plus 10% talc. Make a blend, properly mix it, and follow with the same procedure by pouring it into the funnel, and you will get the circle from that heap. Okay. Similarly, again the next fresh 50 gram granules. Now this time you have to add 1% magnesium sulfate. Okay, and then in the next batch 50 gram you have to take the granules and 5% magnesium sulfate. And in the last batch you have to take again fresh 50 gram granules, but this time you have to add the magnesium stearate 10%. You have to make a blend of that, pour it into the funnel, and then you will get the heat of the powder, and then you will get the circle. So I can say it is how many circles you are getting. First circle, it is with only granules. One, then second, third, fourth, fifth, sixth, seventh. Means these six batches, it is along with glidant and lubricant, as you can see over here, six batches. But one batch, our initial batch is there, which is only with the granule. I hope you are understanding it. Okay. So similarly, you have to follow the same procedure all the time. Okay. Now, one more thing. I guess you got all the things now. You are having the 7 circles from that heat because you have made the 7 batches. Okay. All the time, what you have to do? All the time, whenever you are getting the circle onto the graph paper, every time with every batch, you have to find out the height. You have to find out the height, measure the height of the heat. This is the height of the heat. Height of the heat. Okay, from the bottom, you have to put the scale, and then you have to measure the height of the heat. Top portion up to the bottom, that would be height of the heat, and it should be, this measurement you have to take for all the heat, means for all the 7 batches. For all the 7 batches, you are going to find out the height. Obviously, it would be same, but 7 times you have to repeat that. Okay, so height of the pile, or you can say heat. Height of the pile, you can mention over here. Height of the pile, every one batch, second batch, third batch, that you have to mention over here. Obviously, it will going to come the same, okay, all the time, but still you have to measure that. Okay, question. And weight of the granules you have to take a 50 grams over here, as you can mention over here. Now what to be done? So simple. I guess you have understood this procedure. What we are having now 7 circles, and height also we are having. Okay, so what to be done? 7 circles are there, 7 diameters are there, 7 different diameters of different batches are there. You have to find out the diameter of each batch. You have to find out the diameter of each batch. You will definitely going to get that. And when you are getting the diameter of each batch divided by 2, you will get the radius of each batch. Okay, radius of each circle. So in this manner, you have to get the radius of each. Okay, radius of each. Okay, so here they have shown the average. I am taking directly that with one batch, one radius. I am not taking the average. Okay, further I am not taking the average. I am straightaway taking the one batch because we have to do all the things. Actually, ideally what you have to do, you have to repeat every batch 3 times, and then you can take that. Ideally, you should do that. But for the explanation, everything is the same. Okay, for the explanation, I am skipping this average point. Okay, so what I am guessing that you are having 7 batch, 7 circle you are having. Take the R of that, radius of this circle. Easily you can get. Okay, so now come to this column. H upon R. H upon R. It is the height of the heat, height of the pile divided by R of first circle. First circle means which batch? The batch contained only with the granules. You got the circle of that. The batch contains only with the granules. Uska R le lo. You can take the R of that. So height is there, R is there, H upon R. H upon R mentioned over here. Okay, in the 6th column, H upon R. In the column of H upon R, you have to mention the value that you got for the first batch. Basically, it is a pure granules only. Nothing you have added. Okay, then you have to you already got the height and radius of the next batch, which is this one, 50 gram granules plus 1%. You got already got the height of that and radius of that second circle. Okay, mention over here. Similarly, you have to mention H and R, H upon R calculation for all the circles for all the batches. So particular value you will get, and here that value you have to put it over there, H upon R. Okay, and take the tan inverse of that value. As you can see over here, it is the first batch only sample. Then second batch sample plus talc 1%, H upon R. Then theta you have to calculate. How you are going to calculate the theta? It is the tan inverse of H upon R. Tan inverse of H upon R. H upon R you will get it from the practical that you have done. So it is so simple practical. H upon R you will get, take the tan inverse of that, you will get the theta. So you have to do this thing with all the batches. You have to do this thing with all the batches, and you will get the theta for all the batches. Okay, theta for all the batches. So further calculation, this thing we have already done. Radius we got from the diameter divided by 2, we get the radius. We have already calculated the radius for all the batches, all the circles that we have obtained. We have find out, we got the radius of all the batches. Okay, further we have to take the average of that. Okay, so I'm skipping this average. Again I'm skipping this average. You can straightaway take the radius of all the batches. Okay, it should be mentioned here. And in this case, you will find out the H upon R. Earlier we have done, and then you have to find out the theta of that by taking the tan inverse of the value that you obtain for H upon R for each batch, for each circle. I hope you are understanding the thing properly. Okay. So in this way, whatever the angle that you are getting, the angle of repose of sample 1, 2, 3 for all the batches you have to mention here. Okay. So if now come to our this table again, which I have already explained you. If the angle that we got with all the batches, okay, means all the batches we will get the different angle. Why we will get the different angle? Because every batch is composed with different composition. One batch is purely granule, second batch is a granule plus 1% talc. Okay, another batch is a granule with you can say 5% talc. Another batch granule with 10% talc. Another batch granule with 1% talc, 1% magnesium chloride. Another batch granules with plus 5% magnesium chloride. Which every time we have done with different batches. Obviously, the flow of powder will be different. The flow of powder will be different, and so that the angle that you are getting, it would be different. Now, lastly, which is that angle needed to be considered? Come to our list. The angle to be considered, it is this one. This is the bottom line, horizontal plane, and this is the inclined plane. This angle, okay. This angle we need to consider. This is the inclined plane. Okay, the angle between the horizontal plane and the inclined plane. Okay, that angle you can consider. If it is so obvious to understand, if the angle between these two lines, the angle which we got, if it is smaller, obviously we can say that the granules are too much flowing over one another. Means in another way you can say the granules are sliding over one another, and if they are sliding over one another, obviously the angle which they will get, it is smaller. So that You can say if smaller will be the angle, if smaller will be the angle, flow would be excellent, and we have categorized this that angle. If it is lesser than 25, if it will be 20, 15, means we can say that all the granules have already slided over one another very nicely, so that it is not it is not residing. The particles are not obstructing one another, and the flow of powder is excellent. If the angle would be more, obviously the heap height would be more, and the flow of powder, flow of granules would be poorer. So that if the angle would be more, then poor flow. If it is more than 40, then very poor flow is there. Okay. I hope you understood this. Okay. Now I am going to share. So on your WhatsApp group, I am going to share a link of video. Actually, I have already shared uh, in our app. So you might have seen that. So you can refer that. Whatever I have explained, it has been shown over here. You will get a clear understanding of the today's practice. Okay, whatever I have explained over here. But in that video, it is very, you can say, in a short form, it has been elaborated. But at least you will get a practical view of that procedure what we have discussed now. Okay, so as I mentioned over here, you have to uh, mention the angles for different samples as a result of this experiment. Okay, so I hope you got the clear understanding of today's practical. Further, we will take the next practical on the viscosity. So with this, we are ending our broadcast. Thank you very much.